Sometimes the biggest breakthroughs come from the most personal places. We're going to talk about a story that starts with a promise made at a hospital bedside and ends with an AI-powered hunt for cures that are hiding in plain sight. It's an incredible journey. So this is the promise that really started everything. Picture this. David Feigenbaum, he's just an undergrad at Georgetown, and he makes this vow to his mother while she's dying from brain cancer. He says, "I'll dedicate my life to finding treatments for people who'd run out of options." It's a promise born from just absolute heartbreak, and little did he know it was about to be tested in a way no one could ever imagine. And that test, it came way sooner and way harder than he ever could have guessed. He went from being a doctor in training to patient zero in a desperate fight for his own life. I mean, his decline was just terrifyingly fast. One minute, he's this promising med student, and the next, his organs are shutting down. He gets this diagnosis, Castleman disease, a super rare and just relentless immune disorder. And the thing is, the world's top experts, they were totally stumped. He kept relapsing over and over until one day, the doctors they had nothing left. They told him he was out of options. They actually read him his last rites. But here's the thing about David. He just refused to accept that as the end. With his back completely against the wall, he reached for the only tool he had left, his scientific mind. He decided, okay, I'm going to turn my own illness into a research project, a clinical trial of one. And the patient was him. So he got methodical. He started collecting and analyzing his own blood samples, just hunting for any kind of clue. And then he found it, a critical piece of the puzzle, an overactive immune pathway called MTR. Now, from his med school training, a light bulb went off. He knew there was a drug, sirolimus, it's used for kidney transplants, that could literally turn that specific pathway off. So he went to his doctor and said, hey, let's try this. He convinced them to give it a shot. And it worked. It actually worked. This repurposed drug, meant for something completely different, saved his life. And that moment, it was so much more than just a personal victory. It exposed this massive blind spot in our whole healthcare system. It made him ask, what if the cures we need are already sitting on the pharmacy shelf, just waiting for us to find them? And that question led him to a truly staggering problem. See, his disease, it was just one of, get this, about 14,000 other conditions that have absolutely no approved treatment. None. Let that sink in. 14,000. So David realized, okay, this isn't just about me anymore. This is about every single patient who's ever been told, sorry, we're out of options. So he co-founded a nonprofit, Every Cure, with one mission, to take what he learned from his own fight and scale it up into a solution for everyone. And the whole idea behind it is something called drug repurposing. It's basically about taking a medicine that already exists and asking a really simple but powerful question. What else can this do? The goal is to unlock the full potential of every single drug we've already got, to see if it can treat something it was never designed for. And think about it, this could save billions of dollars and years of time because we already know these drugs are safe. Okay, so let's look at the sheer scale of this problem. On one hand, you've got about 4,000 approved drugs. On the other, we know of around 18,000 diseases. And don't forget, thousands of those, like David's, have zero treatments. That gap between drugs and diseases is just massive. But it's also filled with all these potential hidden connections. So that leads us to the million-dollar question, right? Or maybe the $75 million question. If you have 4,000 drugs and 18,000 diseases, how many different pairings do you have to check to find every single one of those hidden cures? The answer is about 75 million. 75 million possible drug disease pairings to investigate. That number is it's mind-boggling. There's no way any team of humans could ever get through that. The search space is just way, way too big. Yeah, a task like that is pretty much impossible for a human brain. But it's not impossible for AI. In fact, it's exactly the kind of massive, data-heavy problem that AI was built for. And this is where it all comes together. Every Cure built an AI platform they call Matrix. What it does is it just sifts through these enormous piles of biomedical data. We're talking everything from clinical trials to scientific papers. And it predicts which of those 75 million pairings are the most likely to actually work. It turns an impossible search into a ranked, prioritized list of hope. And listen, this isn't just some theory on a whiteboard. It's already saving lives, for real. The AI has already pointed to new treatment options for angiosarcoma, a really rare and deadly cancer. It found an existing therapy that saved a young girl in Chicago when nothing else was working. And it's even shown that a drug for sleeping sickness might help kids with a rare neurological disorder. These aren't just data points, you know? These are real people, real families getting a second chance. But what's really incredible here is the speed. I mean, the acceleration is just insane. When the Matrix system first got up and running, it took 100 days to crunch through all the possible matches. Today, it does the same thing in just 17 hours. That's the difference between a cure being a theoretical idea and a patient actually getting that medicine in time to save their life. And here's a really crucial part of their model. It's all about collaboration. Every cure doesn't hide their work. They publish all of their AI's predictions publicly, for free. The goal isn't to create some proprietary advantage and make a ton of money. It's to create a shared public good, a resource that any researcher anywhere can use to find treatments faster for everyone. And that really brings us to the core vision behind all this work, right? It's not about machines replacing people. It's about using these incredible machines to magnify the best parts of us, our empathy, our intelligence, and our desire to help one another. So that leaves us with a really powerful final thought. If this approach can systematically find answers for thousands of diseases we thought were untreatable, what other impossible problems could we solve? What else is out there just waiting for us to combine our human ingenuity with the incredible power of AI?